Now, sometimes we want to go one step further and we want to predict the whole time series of a certain type of event. Typically, when managing the production of goods, you want to be able to anticipate what will be their sales in order to match the production accordingly. Let's retake the first example of this training, where we had different SKUs with different volumes of expected sales and variabilities. Anticipating the production was an issue, particularly for the wild bulls, where we expected large sales, but we also knew that those sales could be highly variable. Hence we said that you should treat them on a case-by-case basis. Let's do it. And let's take a specific SKU to try to understand it better. Now let me unveil which product we have in front of us. We are actually talking about a specific chocolate bar. As a chocolate bar manufacturer, it's important to be able to forecast the sales accurately in order to allocate the right quantities of bars in store proactively. On the one hand, should you have too much chocolates in store, your inventory management won't be efficient. You will waste a lot of money by placing products on the shelves that will not be purchased. Without speaking of the products that passed the sell-by date and will be discarded anyway. On the other hand, if you underestimate the demand, it may even be worse. Your turnover will be impacted negatively because you fail to sell products you could have sold otherwise. The problem is that the sales of chocolate bars are typically varying over time. You have certain periods where customers buy less, and others when they buy more. Let's look at those sales over time. We see that we have peaks and valleys. The sales can go up to 1,000 units in one month and go very low during another one. But we also see that there is some kind of regularity in the time series. Maybe we can identify patterns that could be used to build a model and therefore improving our prediction ability. If we succeed, even though the sales are varying a lot, we could decrease our uncertainty about it to an acceptable level. We would then tame the wild bull. Let's test if by using the month of the year as an unexplanatory variable, we do a good job at modeling the sales. We can then estimate in R what's the effect of the month using a simple linear regression where the sales would be the dependent variable. And we see indeed that many months have a very strong effect on sales. Remember that as soon as you see a star here, it means that the explanatory variable has a significant effect on the outcome. And 3 stars means that the effect is strongly significant. We see that December, November and February have on average a positive effect on sales. The sign of the estimate is indeed positive in those cases. And also that the months June to September report a decrease in sales on average. It's not surprising if you are in a northern hemisphere country. Those months are actually the hottest of the year. And people tend to buy less chocolates when it's hot. Reciprocally, with the coldest months of the year, people will eat more chocolates then. And if you are in a country like France, for instance, it's not surprising that people's consumption of chocolate peaks around Christmas, which is in December, where we have the largest and positive estimated effect on sales. As usual, we should find a visual way to report those results. And we could, for instance, use box plots, as we do here, to report the distribution of sales per month. A box plot allows for different cases, here for different months, to report the distribution of a certain value, here the sales. It summarizes nicely the distributions of sales per month. The box itself contains 50% of the values of a specific month, and the bar within the box reports the median value. As usual, here I just present quickly this approach, but I would advise you to investigate all the information a box plot can report. It's something really useful in practice. In any case, it allows to compare in a very visual way the differences between the months. And we see clearly, indeed, which months report large sales and which months report small sales. but does the model do a good job at fitting the variance we've seen before? Let's compare the sales as modeled by our regression and the actual values. We see that the fit is indeed very good. We can therefore use the model we have to forecast what will be the sales for each specific month in the future. And while the sales, seen globally, are highly variable, the variance, given a certain month, is a lot smaller than what we could have expected before. We reduced a lot the uncertainty, and we can now use our ability to forecast future sales to allocate the stocks more efficiently. We will maximize our sales while decreasing our costs of inventory management. This was the last example for this module on predictions and forecasts. You now have the opportunity to go over the recital with Pauline once again.